In TPC Desktop 2021, Release 1 that's due out the summer of 2021, we're modernizing our least squares adjustments. Some of the terms have changed, or we've kind of settled on some new terms, but primarily we're using it for different things. In the example shown here, I've got two GNSS points that I'm starting with over here in the southeast part of the project, and southwest. And here in the northeast part of the project, I've got two GNSS points that I'm tying into. And I could have any kind of a ground traverse between them. So I'm really mixing ground traverse adjustments with GNSS points. But I want to show you some key components here of what's different. So you're going to notice right off the bat, when I come into Miscellaneous, the a priori values that you can set are the stochastic model. And Traverse PC now allows you to set estimates of standard error for these coordinates. So these GNSS points might be tied to a virtual reference station that's some miles away, and they're going to have some error based on those vectors and the length of those vectors. So you can specify the amount of error for the stochastic model, and then of course for the individual coordinates as well. But this would allow me to pick up these nearest virtual reference stations with the rover that I'm working with. So let's go ahead and tell Traverse PC we want to solve this, and it failed the chi-squared test. Let's come into the report then, and let's talk about how Traverse PC is going to help us figure this out. So right away in the chi-squared test, we see that we failed it, and we give you the bounds, and look at this. Our upper bound at the 95% confidence interval is 9.34. We're at 9.92, so we're really not too far away, and that's what we tell you. We say the computed reference variance of 3.31, and that's right up here. Here's our computed reference variance, is statistically different from the a priori value of 1, so our estimated standard error variance of 1. So the standard deviations of computed coordinates of observations below are going to be multiplied by the 1.82. Now, consider using this to improve your stochastic weighting model. So let's take a look at this. We use the exclamation now to say, hey, these two standard deviations are outside of the estimates you gave me. We gave an estimate of 30 seconds. We've got 44 and 35. Also, these standard deviations of this particular residual right here is outside. And remember, we can go up here and look at this. We said for distances 0.05 plus 5 parts per million on the horizontal. So this was outside of it. So what do we do with this? Well, it would be real easy for us to come in this RU here, go back to either our stochastic model, or we can edit individual observations here. Here's the RU, and let's just change this then to 0.1. So we're just changing the stochastic model for this. Let's come back now and resolve that at 95% confidence and see it passed. So let's come in and do this report now. And we can see that we don't have the error on that anymore. Okay. We also can come up and see that our chi-squared value now is at 4.71, well within the range here. And we can see that we changed our reference variance and reference standard deviations just a little bit in the process. You're also going to notice some changes, like in addition to these statistics you've always had, we give you some component statistics below to help you improve your solution. And really what I'm going to do is I'm going to say, okay, I'm actually adjusting those coordinates now, but my average standard deviation for those is really small. Okay, and this isn't multiplied by the 1.25. I'm just using sort of a basic average here. But it's the horizontal components that were much larger. And I really want these values to be as close to 1 as possible. Okay, and that's not too bad. Here I look at the breakdown of the horizontal, and I see it's really not the angles that were at fault here. It's the distance that I was having a little trouble with. And that's why I came in and adjusted the estimated error for this one distance here. And you can see that I changed that to 1/10 of a foot instead of the 5/100 of a foot. So we're trying to give you the tools within the least squares adjustment so that you can easily come in and do all your standard least squares adjustments you've always done, but also start applying least squares adjustments to things like the mixed GNSS and terrestrial surveys that we often find ourselves doing these days. So these are changes coming in TPC Desktop 2021, Release 1, due out the summer of 2021.